In this experiment, we will demonstrate that white light is composed of all visible wavelengths through diffraction. As you may recall from the double and single slit experiment, light will interfere and create points of constructive and destructive interference when passed through a slit, called an interference pattern. Similar to a single or double slit, light will diffract and interfere when passed through a diffraction grating. A diffraction grating is a series of very many tiny slits that are so close together you can't see them without a microscope. However, because there are hundreds of slits so close together, the interference peaks are very sharp. Interference peaks of lower wavelengths are closer together, while longer wavelengths are farther apart. Because of this, different colors will line up at different points on the spectrum. Blue light should be closer together than either green or red light, just like we see with a single or double slit. This video will show how to create and set up a diffraction grating for the activity. We will create a setup using the following: a set of 2 wood blocks, a shallow cutout should be made in one of them, a 1.5 inch diameter PVC tube, a PVC tube cap with a single slit cut into it, a 5 inch diameter by 1.5 inch thick clear plastic tube. Make sure to cut a 1.5 inch diameter circular opening, a diffraction grating and 2 razors, paper and scissors, a white light source, multicolored markers, and clear tape. Next, we will create a ring that will capture the spectrum of the diffracted white light on paper. Take the paper and line up the clear 5 inch diameter plastic ring along the short edge. Cut a strip of paper about as thick as the ring. Then, tape the paper to the outside of the ring. Double-sided tape may come in handy, but regular clear tape works as well. Try to center the strip across from the circular cutout. First, we will make our diffraction grating slit. Cut a round piece of diffraction grating paper about 1.5 inches in diameter. Look at the paper and try to find the angle where the spectrum spreads out horizontally as vertical colored lines. You may have to shine a light through the grating and slit to help determine which way to place the paper. Place the razors with the long edge perpendicular to the vertical color lines and make a 2 to 3 millimeter slit. Tape the tops and bottoms of the razors to the grating. Make sure you have enough tape to attach it to your pipe. To set up the apparatus, first make a T-shape with the wooden blocks, making sure the cutout block is centered and perpendicular to the other block. These will be used to support the tube and keep it from rolling. Next, place the cap on the 1.5 inch PVC tube. Place a mark about 2.25 inches from the capped end. This will help place the ring in a spot where the light will be more spread out and easier to see. Take the diffraction grating slit and tape it on the cap, making sure the slits are aligned. Place the ring on the tube with the cutout on the mark. Place the apparatus on the blocks, making sure the slit is vertical, and shine or place a small white flashlight through the open end. You should see a vertical line of white light in the center, with the spectrum spread out on either side.